Hello, and welcome to your first logistic regression lecture. Now, you may have heard of logistic regression as a classification model because it predicts categories like whether or not you're registered to vote, or whether or not you have blue eyes, or whether or not you're likely to default on a loan. But what I am going to try and get across in this lecture is the fact that logistic regression is just linear regression in disguise. So if I'm going to make that claim, we should probably talk a little bit about some of the differences, or at least the perceived differences, between linear and logistic regression. So in linear regression, which we just covered, we take any number of predictor variables and use them by fitting a straight line or plane to predict a continuous variable. Whereas in logistic regression, we are predicting binary categorical variables. In other words, a 0 if you're not in a certain group and a 1 if you are. For example, in the example I gave before, you might have 1 mean registered to vote and 0 mean not registered to vote. So if the claim that I made is true, that logistic regression is just linear regression in disguise, then we have to find a way to put these two things that seem pretty separate together. And the way that we do that is by doing a bunch of math, of course, on the binary categorical variable to transform it into a continuous variable so that we can just use linear regression to predict that transformed continuous variable. Here's an outline of the steps that we're going to take, but let me take it one step at a time. The first thing that we're going to do in order to take this journey from binary to continuous is to think about our predictions in terms of the probability that someone is in a given class. For instance, in the registered to vote example, we would say, instead of just predicting 0, they're not registered, or 1, they are, we'll predict a probability that they're registered. And that's already one step closer to where we need to be, because instead of having just a 0 or a 1, we are now allowing our values that our model predicts to be any number between 0 and 1. So we're one step closer. The next step after converting to probabilities is to turn those probabilities into odds. And we mentioned at the very beginning of this course that odds are just a different way of talking about probabilities, and the way that we calculate them is the probability of an event happening divided by the probability of that event not happening. And this is just a way to say how many more times is it likely that the event will happen as will not happen. And as we explored in one of the first classes, odds now have a range of 0 to positive infinity, with 0 being the odds when the probability is 0, and up to infinity being the odds when we get a probability close to 1. So again, one step closer. The last step in this process from binary to continuous is to take the log of those odds that we just created. So in other words, we're going to say log of p over 1 minus p. And when you take the log of odds, which originally had a 0 to infinity range, the log odds now have a negative infinity to positive infinity range. And we've essentially created a really nice behaved continuous variable out of those 0s and 1s that we had before. Really quickly, I just want to go over the kind of relationship between odds and log odds. On the screen, you can see odds are down here and log odds are up here. And you can see that for odds that are very close to 0, we're going to get negative log odds. Whereas when odds are larger, pretty much from here to infinity, we're going to get positive log odds. So the final formula that we have after we've done all of those steps of converting from a binary variable to a continuous one is that the log odds, and that's what this is here, log odds, is equal to something like mx plus b. In essence, logistic regression is just linear regression, but predicting log odds instead of predicting binary zeros and ones. Now, before I end here, I just want to point out some useful kind of thresholds for probability, odds, and log odds, because we'll often be talking about all three of these in the context of logistic regression. So let me scroll up. So in terms of probability, which is probably the most intuitive to us out of these three, the probability 0.5 or 1/2 is really meaningful, because when you have a probability higher than 0.5, it means that an event is more likely to happen than not. And when you have a probability lower than 0.5, you can see that it's less likely to happen than not. In terms of odds, the threshold that you want to remember is 1. When the odds are 1, it means that the event is just as likely to happen as to not happen. And so anything greater than 1 indicates that it's more likely that our event will happen, and anything less than 1 indicates that it's less likely to happen. In terms of log odds, the threshold that you want to remember is 0. Log odds greater than 0 indicate an increase in the likelihood that something will happen, and similarly, any log odds that are negative indicate a decrease in the likelihood that something will happen. Okay, that's all I have for you today. It should be very short. Go ahead and watch your Python lecture, but I will see you next time.